Hello, hello, and welcome to a little video about zero and negative exponent powers. Okay, so first let's refresh some vocabulary. Here I have 8 to the power of 2, or 8 squared. Both of those would be the correct way of saying it. 8 is the base, 2 is the exponent. You're also going to hear it called the index, or sometimes I will personally refer to it as a power. So the base number, so in this that big 8, the big number, B, big, base, that's how I remember it. The base power is, or the base number is a number that gets multiplied by itself. It is the number to which we raise a power. So for example, a 2 with a little 3 up top is 2 to the third power, or 2 cubed, right? 3 can be also said as cubed. 2 is the base number, the 3 is the exponent, or also the power. The exponent is what is the number that tells us how many times we multiply the base number by itself. How many times we multiply the base, B, big number, by itself. So 2 to the power of 3 means we multiply 2 by its own self 3 times. So 2 times 2 times 2 is 8. For example, we've learned a lot about square numbers in arithmetic. So anything to the power of 2, so 8 to the power of 2, 8 squared is 8 times 8. Or if we have something larger like 9 to the power of 4, it's 9 times 9 times 9 times 9, which gives us a nice big 6,561. So let's just rewrite these powers. So take a moment, rewrite all of these powers as multiplication, like they are written up top. So if you're watching this, pause the video. If you're doing it with me in class, I would have been giving you some time to work. Here we go. So hopefully you've taken time to write this down. Unpause the video. Here we go. 2 to the power of 3 is 2 times 2 times 2 times 2. 2 to the power of 4, same thing, 4 times. Oh, let's actually solve that. 2 to the power of 3 is 8. 2 to the power of 4 is 16. Of course, you can use a calculator for this. 3 to the power of 3 gives us 3 times 3 times 3, which is 27. 1 to the power of 3 is 1 times 1 times 1, which is 1. Negative 2 to the power of 3. This is a weird one. See how negative 2 is in parentheses? I want to make sure to leave it in parentheses. Negative 2 times negative 2 times negative 2 gives us negative 8. Negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. A negative number raised to a positive, to an odd power gives us a negative answer, like negative 2 to the power of 3. A negative number to a even power gives us a positive answer, like a negative 2 to the power of 4. Now over here, this is different. Negative 2 to the power of 3 is actually negative 1 times 2 to the power of 3. I know that's weird, but when we have a negative in front of a base number, it's actually a negative 1 out front. It's that invisible negative 1. So what this really is negative 1 times 2 times 2 times 2, which is negative 8. And you're probably saying, okay, that changed nothing. It's the same as negative 2 to the power of 3. You're right, and that's because that's an odd power. So an odd power kept things negative. So let's see what happens when we do the same thing with an even power. So we have a negative in front of the 2. Now, I did forget to mention that our bases are always positive numbers. So if we ever have a base that's negative without parentheses, there's that -1. Maybe I did mention it. I don't know. We're 5 minutes in, so I'm going to continue. Anyways, we have -1 and then 2 4 times. So we get -16. So there's our difference. -2, right, or when we rise it to the power of 4, we're taking -2 and multiplying it by its own self 4 times. When we have a negative and then a 2 to the power of 4, there is that implication of a -1. Okay, so if the base is negative, but the negative is not in parentheses, the base itself is positive. I know it's kind of weird, but this is a difference. And when you're using your calculator to put in -2 to the power of 4, you have to be careful and make sure you're putting it in the right way. If -2 is in parentheses, keep it in parentheses. If not, don't. It makes a difference. Okay, now that we reviewed some exponents, or what exponents are, let's take a look at properties of exponents, because now we're not just going to be dealing with bases that are numbers, we are going to be dealing with bases that are variables. Zero property of exponents states that any number or variable raised to the power or to the to the 0 power is 1. Anything, literally anything to the power of 0 is 1. 4 to the 0 is 1. 2.5 to the 0 is 1. X to the 0 is 1. 181 to the 0 is 1. Okay. Negative exponent rule. A non-zero number or variable raised to a negative exponent is the reciprocal, and we'll go over that, of that number or variable to the positive exponent. A reciprocal is a word that's related to fractions. Reciprocal really means is take our fraction and flip it. So a negative exponent tells us that we are on the wrong side of the fraction line. Flip me. So here's the two examples I have. 3 to the power of -2. Remember the rule that states that every whole number is actually a fraction over 1? The reciprocal of 3 to the -2 is 1 over 3 to the positive 2. So negative exponent, we did the reciprocal, so we flipped the fraction, and we have a positive exponent. And then we were able to solve it. The same thing goes if the negative exponent is in the bottom of the fraction, in the denominator. A to the power of 3 is actually a to the power of 3 over 1. So we did flip it, the 1 and the a to the power of 3. A to the power of 3 went to the top, to the numerator, and became positive. Let's do some examples. Letter E, we got -2 to the power of -2. Since -2 is in parentheses, we will keep it that way. Whoa, whoops. Let's scroll back to that. Okay. So first, I'm going to rewrite it as a reciprocal. 1 over -2, and I'm going to make sure the exponent is positive. Okay, now that I've rewritten it, these are all numbers, there's no variables, I can solve it. -2 to the power of 2 is 4. Our answer is 1/4. Letter F. Okay, there are There's no numbers to deal with, so all we can do is rewrite this as a positive exponent, since we only have a variable. The negative exponent is in the denominator on the bottom of our fraction. So we're going to put it onto the top of our fraction as a positive exponent, and then a 1 on the bottom. Really, we could just write it as y to the positive 17. Try doing the same thing as you did in letter E for letter G. So if you're following along in the video, give it a pause, try it out, then I'll unpause it, and you'll watch me do it. Alright, so I'm going to put a 1 on the bottom here because we're going to make a reciprocal because of the negative exponent. We're going to put the base 3 on the bottom and then make the power positive. This one we can solve. 3 to the power of 3 is 27. So our answer is 1 over 27. Okay. If you were in class, I would have you solve these. Just like I said, you'd pause it, unpause it. So if you're following along at home, pause it, unpause it. Try these on your own. But I'll talk us through them now. Hopefully, you've taken a moment to try. Okay, x to the negative 7th, we're going to flip it, put it in the denominator as x to the positive 7th. And that's as far as I can go. Letter I. I'm going to make the fraction line. I'm going to take the negative exponent from the bottom. I'm going to put 4 to the positive 2 on top. 4 to the power of 2 is 16. 16 over 1 is really just 16. And letter J. Ooh. What has the exponent? The 2 or the x? The x. So the 2 stays. We're not flipping that. We're only bringing the x to the bottom. That's as far as we can go. Letter K. 4 does not have a negative exponent, so it stays up top. X to the power of 4 goes up with it. And really, we can rewrite this as 4 times x to the 4th. Whoops. Just like the previous one, the 7, or the two previous? Yeah, like letter J, the 7 does not have a negative exponent, so we're going to be keeping 7 in the numerator. But y to the 5th goes down to the denominator. Ooh, we got 2 negative exponents. Well, that means 2 to the negative 2nd goes to the bottom as 2 to the positive 2nd, and 4 to the negative 3rd goes up top as 4 to the positive 3rd. 4 to the power of 3 is 64. 2 to the power of 2 is 4. And we could simplify that even further. 16. Alright, letter N. Ooh, that's combining everything here. The 4 does not have a negative exponent, so it stays. X to the power of 0 is 1. Y to the power of negative 3 goes up top and becomes y to the positive 3. And let's simplify this a little further. I can multiply 4 and 1 up top in the numerator. 4 times 1 is, 4. And y to the 3rd stays y to the 3rd. Lastly, let's take a look at letter O. Wow, that has a lot. We have a negative exponent, so I'm going to make this a fraction. Alright, let's go through this one by one. 8 does not have a negative exponent, it stays. X to the negative 7th goes to the bottom, becomes x to the positive. Y to the 0 becomes a 1. And z to the fourth stays z to the fourth. Can simplify that a little further by multiplying 8 and 1. So that's just 8. Z to the fourth over x to the 7th. All right, beautiful. Never mind. I thought that was it. We got 2 more to do. Let's try them. Letter P. Whoops. Letter P. Got 2 to the 0. That's gonna give us 1. Because anything to the power of 0 is 1. X squared stays there because it's a positive exponent. And then y to the power of 2 goes up top. Let's simplify this. This just really ends up being x squared y squared. And then finally Q. Wow, okay, we got some negatives, some positives, ooh, some zeros. Okay. 3 to the negative 2 I'm going to put on the bottom as 3 to the positive 2. X to the negative 5 becomes x to the positive 5. Z to the 5th stays up top. In the original bottom, 2 stays on the bottom. Y to the 0 also stays on the bottom, but y to the 0, remember, that becomes 1. And let's simplify. Z to the 5th is just z to the 5th up top. Nothing changes about that. I can multiply all of these numbers on the bottom. So 3 squared times 2 times 1. That gives us 18. And x to the 5th is just x to the 5th. Perfect. Alright, so those are just 0 and negative exponents. So make sure to remember, if anything is raised to the power of 0, the answer is 1. And if we have a negative exponent, that means it's on the wrong side of the fraction line. We've got to create a reciprocal and make it a positive exponent. Alright, if you got any questions, let me know. Whoever else is helping you know. Otherwise, have a wonderful rest of whatever day it is for you. Bye.